Hello friends, you are welcome to yet another video of your YouTube channel Tech Guru Gautam Prasad. Here we are going to discuss power triangle and power factor. We have seen earlier this impedance triangle which consists of impedance as the diagonal of the right angle triangle, resistance as the base of this right angle triangle, and reactance as the perpendicular of this right angle triangle. So all these three things, resistance, reactance, and impedance, can be shown as the part of a right angle triangle. So net reactance of the circuit uh, depends on the inductive reactance and the capacitive reactance. The reactance is the sum of these two reactances, or the differences of these two reactances, because one of the reactance is negative. The summing them actually brings the difference of these two reactances. And resistance is pure resistance, and impedance is the impedance of the circuit. So this thing is very important to understand the power triangle. That is why it was important to discuss the impedance triangle first. The angle between impedance and the resistance, that is the diagonal and the base of the triangle, is phi. And this is nothing but the phase angle, net phase angle between voltage and the current. So in any electrical circuit consisting of resistance and reactances, inductance and capacitance, there will be a phase angle which will be leading or lagging in nature. What will be the angle of phase angle of lead or lag? That is decided by impedance and this resistance. Impedance is the net of resistance and reactances together. So the angle uh, between voltage and the current is basically the angle between resistance and the impedance of the triangle here, right? Now let's proceed to the impedance triangle again. That same thing has been explained. Let me explain you. Z square is equal to R square plus jx square, and x being the reactance part. Cos phi is equal to R upon Z, sin phi equal to x upon Z, and tan phi is x upon R. That is perpendicular divided by base. Sin sin phi is uh, perpendicular divided by uh, diagonal uh, hypotenuse of the triangle. Cos phi is base by hypotenuse of the triangle. So that is what it is. Also, we have studied already that in this type of circuit, we have a real power, which is the multiplication of the square of the current and the resistance. And this is measured in watt. That also we had discussed. The real power is measured in watt, and this is equal to I square R. The reactive power, that is Q, is I square X. X is the net reactance of the circuit, and this is measured in volt amperes, and volt amperes reactive, and it is represented as VA, small r. Apparent power, S, is the total power in the circuit, total power consumed in the circuit, and that is equal to I square Z volt amperes. This is measured in volt amperes. And so that is what power, these three types of the power inductive circuit has: real power, reactive power, apparent power. So these three powers can also be shown in the form of a triangle, and that is called power triangle. So I'm scrolling down to that triangle. Here is the power triangle that we were talking about. Here Apparent power is represented by S, and that is equal to V into I, and it is measured in volt amperes, as I told you earlier. And reactive power is Q VI sine theta, VI sine theta, or VI sine phi. So this is measured in volt ampere reactive, VAR, and the real power is measured in watts, and P is equal to VI cos phi. And apparent power, of course, being the being the hypotenuse of this right angle triangle, is equal to S equal to a square root of P square plus Q square. Uh, that's all in this video. But there is a numerical that I will discuss here. So power factor is equal to watts divided by volt amperes, or you can also say it is active power or real power or true power of the circuit divided by apparent power of the circuit. So VI cos phi divided by VI, VI cancelled out, and cos phi is the remaining. So this is power factor of the. So it is ratio of the active power by apparent power. So power factor is zero, cos 0 degree. If there is no reactance in the circuit, only resistive circuit is there, then the power factor is going to be 1, and that means voltage and current are in sync. That means there is no phase difference. Okay, and here real power is equal to apparent power into power factor. So here is the example that I was talking about. Power triangle is given. Power triangle example number 1. So this is a circuit which is consisting of a resistance and inductance. Resistance is 35 ohm and inductance value is 180 millihenry, and 100 volt RMS 50 hertz supply has been applied on these two elements. So here is the question. A wound coil has the inductance of 180 millihenry and a resistance of 35 ohm, is connected to 100 volt and 50 hertz supply. Calculate impedance of the coil, the current in the circuit, and the power factor, and also the apparent power consumed. Also draw the resulting power triangle for the above coil. So the data given is R is 35 ohm, L is 180 millihenry, B is 100 volt, and F is 50 hertz. Now let's start calculation. R is 35 ohm, XL equal to 2 pi FL. So calculate it directly. You will get 2 pi multiplied by 50 hertz multiplied by 0.18. This is 180 millihenry. So 180 multiplied by 10 to the power minus 3 is 0.18. So multiplying all these will give you 56.6 ohms. Now, having got XL and R, you can calculate Z. Z equal to R square plus XL to the square root. After summing the squares and getting the square root, you will get the value of the Z to be 66.5 ohms. Now let's calculate the current in the circuit having got Z. So you can calculate I equal to V upon Z. So 100 volt is the supply, 66.5 is the value of the Z. So dividing all these two will give you 1.5 ampere is the current. Now finding out the power factor and the phase angle. Cos phi is R by Z, sin phi is XL upon Z, tan phi is XL upon R. So let's use cos phi. Cos phi is R by Z, so 35 by 66.5, substituting the values of R and Z, you get 0.5263. And if you take the inverse of 0.5263, you will get the power factor angle or the phase angle. So you get 58.2 degrees, and this is the angle with which your current is lagging. because the circuit is inductive. Uh, Apparent power consumed by the coil is P is equal to VI cos phi. So this will give you 79 watt. Q is equal to VI sin phi. This is 127.5 VAR. And S is V into I, 100 into 1.5, 150 volt ampere. So your real power is 79 watt, whereas your reactive power is 127.5 VAR, whereas your apparent power is 150 volt ampere. So S equal to P square plus Q square. So if you square these two values, 79 square 1 plus 127.5 square, and you get the square root of the sum, then you will get 150 volt ampere, and this verifies the relationship between S, P, and Q. Power triangle for the coil is drawn here. So having got the value of P, Q, and S, now you have to substitute these values according to their, magnitude. So 79.1 is the least magnitude. So base is small. Uh, More than this is 127.5 is the value. So accordingly, this is longer than the base, and hypotenuse is the longest. That is 150 volt ampere in the power triangle. So the power triangle and the power factor summary as the last part. We have seen that the three elements of the electrical power, real power, reactive power, and apparent power in the AC circuit can be represented by three sides of the triangle that is called power triangle. As these three elements are represented by right angle triangle, there is a relationship S square equal to P square plus Q square, where P is the real power, Q is the reactive power, and S is the apparent power of the circuit. We have also seen that in the circuit, quantity cos phi is called power factor. Power factor, all these things are discussed. So now you can better understand what the power factor is, having discussed the reactive power, active power, and apparent power. So this is an angle between apparent power and the active power, right? So in terms of that also, or if you remember the impedance triangle, then also you can explain it as the angle between Z and R. So if you want to take the value of cos phi, it is base upon hypotenuse, that is R upon Z. So cos phi is equal to R upon Z, as we had already seen. So that's all for this video. I hope you have better understood the power triangle, the impedance triangle, and the relationship among various terminologies like uh, active power, reactive power, and apparent power, and Z, R, and X. Right. So hope better understanding you have got, and if you appreciate the video, you can tell me your feedback in the comment, and tell me how I can improve this video, uh, or I can make this video better for you. Thank you very much for being with me. Stay tuned for more videos, and subscribe yourself to my YouTube channel. Thank you so much.